Good morning, students. This is Nagaraju, lecturer in electrical engineering, Government Polytechnic Station, Kanpur. Today, we are going to learn about AC motors. So, what are the AC motors? So, we will compare all the AC motors and we will focus on synchronous motors today. Okay, so introduction to synchronous motors and principle of production of a rotating magnetic field is the topic today. So first, what is the AC motor? Then what are the AC motors available? We will compare. Then we will go for synchronous motor. Okay. So objectives of today's class: classification of AC motors, comparison with synchronous motors. So in AC motors, there are different types: synchronous and asynchronous motors. Asynchronous motors generally are the induction motors. So we will compare synchronous motors with asynchronous, means induction motors. What is AC motors and applications of AC motors, where we will use all these types of motors and advantage and disadvantage of different types of motors. Then what is rotating magnetic field? In three-phase, when we give three-phase balanced supply to the stator of the motor, there is a production of rotating magnetic field. How the rotating magnetic field is produced and what is the speed of the rotating magnetic field and what is the necessity of the rotating magnetic field, we will learn today's session, and how the rotating magnetic field is produced. Okay, so first, what is this? So this is the AC motors, electric motor. What is the function of the motor? Motor is a device which converts an electrical energy into mechanical energy. Electrical energy into mechanical energy. Types of electric motors. There are number of types of synchronous motors and asynchronous motors. In synchronous motor, depends on the rotor construction. Permanent magnet synchronous motor, shaded pole type. Different types of synchronous motors are available, and different types of asynchronous motors are also available. All these motors are AC motors. Okay. Coming to the synchronous motor, it is the constant speed motor. Constant speed motor means synchronous speed. Synchronous speed, it depends on frequency of the system and number of poles of the stator construction. How many number of poles constructed on the stator and what is the frequency of the supply system. This will decide the speed of the motor. Synchronous speed of means if we run the motor on load or no load, its speed always constant. If you take induction motor, for example, it is run on 1440 rpm. When we apply load on the induction motor, its speed will reduce. Its speed will reduce. If we increase the load, speed again reduces. But in synchronous motor, the speed is constant irrespective of the load. Irrespective of the load. Okay, and in synchronous motor, we need a DC excitation, a DC excitation per the rotor, because here we will use the magnetic locking function. Stator and the rotor magnetic locking function. In stator, we will give three-phase supply and we will produce a rotating magnetic field. For rotor, we will apply a DC supply. DC supply and we will produce north and south poles. These north and south poles interlink with the stator. Based on magnetic coupling, the motor will rotate. Okay, it can improve power factor. So one of the great advantage of synchronous motor is the power factor improvement. It is also called as power factor compensator. Power factor compensator or condenser, rotating condenser. So it will improve the power factor. So based upon the input excitation, field excitation, overexcited synchronous motor act as the power factor compensator. Overexcited synchronous motor act as power factor compensator. Okay, synchronous speed ns is equal to 120 F by P. So coming to the synchronous motor, in the previous semester we learned about DC generator and AC generator. DC generator and AC generator. Okay. So in the DC generator and DC motor both are constructionally same, but the operation is different. Constructionally same, but the operation is different. If you take a DC generator, if you give mechanical input to the rotor, a DC output will produce. If you give a DC input to the stator and it acts as a motor. Same machine we can use as a generator and motor. Similarly, synchronous machine can also be used as synchronous generator and synchronous motor. Okay, synchronous motors based upon the input supply, single phase motors are available and three phase motors are also available. But the main drawback of the synchronous motor is it has not a self-starting motor. It has not a self-starting motor. To self-start the motor, we need one additional device. An additional device maybe damper winding or a pony motor or a induction motor. Different types of input technique we will use. Means we will rotate the rotor of the synchronous motor up to synchronous speed. Then we will apply DC excitation to the rotor. Then north and south poles are produced on the rotor. These north and south poles link with the stator rotating magnetic field. There is a magnetic locking. Then the motor will continue to rotate on the synchronous speed. Here we need one additional device to rotate initially. That's why it is not a self-starting motor. See the synchronous motor. If you see, stator has number of poles and rotor. Here I am taking only two-pole rotor. Two-pole rotor, one north pole and one south pole. And here 120 degrees phase displacement I am giving from here to here R phase, here to here Y phase, here to here P phase, RYP phase. These are 120 degrees electrically separated. Electrical 120 because theta electrical is equal to P by 2 theta mechanical. So that's why here total 180 here 60 degrees mechanical. 60 degrees mechanical. So here I am getting 120 degrees electrical. So 120 degrees electrical. Okay. This machine can also be used as synchronous generator or synchronous motor. Synchronous motor or synchronous generator. See, equivalent circuit of synchronous motor. Equivalent circuit of synchronous motor is similar to the equivalent circuit of synchronous generator as we studied in fourth semester. So, synchronous motor is the same in all respect as synchronous generator except the direction of power flow. Except the direction of power flow. In a motor, we are giving supply to the motor and we will get the mechanical output. In a generator, we will give mechanical input and we will get electrical output. So only the power flow direction is different, but the construction is same. Since the direction of power flow is reversed, the direction of current flow in the stator of motor may also be reversed. Therefore, the equivalent circuit is exactly same as synchronous generator, except the direction of current, except the direction of stator current. Okay. Coming to the AC motors are very popularly used in day-to-day life, especially induction motor. Induction motor also called as workhorse of industry. Workhorse of industry. In almost every industry, we will use synchronous induction motor, AC motors. So depends upon the supply, we can use single phase or three phase motors. So coming to the classification of AC motors, based on principle of operation, we can classify synchronous and asynchronous based on the speed, synchronous and asynchronous type of current, structural features, location. Based on these five factors, we can classify AC motors. So AC motors simply synchronous and asynchronous motor means synchronous motor will run in a synchronous speed irrespective of the load, its speed is constant. Coming to the asynchronous motor is speed is depends on the load. So regulation present here. If we increase the load, the speed also decrease, slip will increase, slip will decrease. Okay, so slip will increase. So it is a slip speed motor, but synchronous motor is a constant speed motor. Based upon the type of the supply, these AC motors can be classified into single phase and three phase motors. Single phase supply available, we will use single phase motors. If three phase supply is available, then we will use three phase motor. Then based upon the speed, we can classify as constant speed motors, adjustable speed motors, variable speed motors. Constant speed motors means its speed is constant irrespective of the load. But adjustable speed motor, here we have two or three steps of speeds available. For example, if we take a cooler, in cooler we have three types of adjustable speeds: low speed, medium speed, high speed. So if you change the supply to the different types of speed connections, means if we put the knob in high speed mode, then the winding connected to the motor is the lower number of the poles. If you change the knob to medium speed, then the poles increase and the speed decrease. Similarly, for slow speed, if we increase the number of poles. So we can adjust the speeds. These motors are called adjustable speed motors. No, variable speed motor. Variable in industry we need some loads different speeds. For that purpose, variable speed motors are available. If variable speed motors are not available, then we need to convert this speed of the motors with the auxiliary device that's, that are called drives. By using the drives, we can vary the speed of the motors electrically. If electrical drives are not present, then we will go for mechanical coupling. We are while changing the gearbox ratio, the speed of the output also changes. These are the uh, costly methods. Directly variable speed motors are available, then it is very less cost to the consumer. Based on the structural features, open type, closed type, semi-closed type. So in open type, all the windings are constructed on the rotor and stator outer surface. In closed type, the rotor conductors are closed in nature, and semi-closed type, the rotor windings are semi-open type are available. These, these are the different types of structural feature motors. Then, according to the location, surface type, submersible. Submersible motors means uh, they are works on the water or cooling in liquid environment. Surface mount motors are mounted on the surface. Coming to the synchronous motor is a constant speed motor. It can be operated over a wide range of power factor based upon the excitation. Overexcited synchronous motor act as a power factor condenser. Coming to the asynchronous motors, induction motors. Induction motor is a variable speed motor. It works with lagging power factor only. It works with lagging power factor only. Advantage of synchronous motor. The great advantage of synchronous motor. The very great advantage of synchronous motor is the power factor can be controlled easily. We can run the synchronous motor. We can run the synchronous motor as lagging power factor, as a leading power factor low, or unity power factor. Okay, and its speed is constant, independent of load. These two are the major advantages of synchronous motors. Power factor correction and the constant speed of operation. These two are the very advantages of synchronous motors. Coming to the disadvantages, it is a not self-starting motor. It is not self-starting motor. We need additional device, either damper winding or a pony motor or a induction motor. Different types of method we need to start the motor. So it is not a self-starting motor. And it is a doubly excited machine. It requires DC supply and AC supply. It is a doubly excited machine. Doubly excited machine, it means it needs AC supply as well as DC supply. And the initial cost is very high because it needs two supplies, and the rotor we need brushes and brush holders because we need to give DC supply stationary to rotating rotor. So we need a commutator. We need a commutator to convert supply to the rotor, or we need at least slip ring or split ring. We need. If we have slip ring, then we need a DC excitation. If we have split ring, we can use AC supply. A split ring will convert AC supply into DC supply. So that ring cost is very high. That's why its initial cost is very, very high. And it cannot be used for variable speed drives as we already know that it is a constant speed motor, constant speed motor. So we cannot use this motor for variable speed drives. For variable speed drives, these are the disadvantages of synchronous motors. If the motor is overloaded, it may fall out of synchronism. It may fall out of step. Means if you take a induction motor, if we apply a load, its speed will decrease. If we apply again load, its speed will decrease. Continuously apply load, then speed will continuously decrease. But in induction synchronous motors, if we apply some load, then its speed is constant. If we increase the load, its speed is constant. Up to some extent, if we increase the load, then its speed is constant. After that point, we increase the load, then the motor come out of synchronism, out of synchronism, and it will stop. Okay, this motor cannot work overload, cannot work on overload. It has a tendency to hunt. Hunting also present in the induction motor, in synchronous motor. Coming to the applications, it can be used as power factor corrector, power factor correction converter. Okay, it is a rotating type power factor condenser. Constant speed applications like clocks, air compressors. Where the constant speed is needed, then we can go for synchronous machine. In clocks or air compressors, we will use synchronous motor and centrifugal pumps. Centrifugal pumps also need constant speed. That's why synchronous motor we can use at centrifugal pumps. Improving voltage regulation of long transmission lines. In long transmission lines, inductance nature is present on the conductors. Due to this inductive nature, the transmission line voltage will decrease. Transmission line voltage will decrease. That's why sending end voltage to receiving end voltage, sending end voltage minus receiving end voltage variation is present. That's why voltage regulation is present. So to compensate this voltage drop, we need to give reactive power leading in nature. Leading in nature. If we connect synchronous motor on the long transmission line, synchronous motor will take leading reactive power that will compensate the lagging reactive power consumed by the transmission lines. Overall, the effect of reactive power is decreased and the transmission line voltage will not fall. So that's why the regulation of the transmission line is very better. Less regulation is present if we use synchronous motor on the transmission lines. Coming to the frequency change, a synchronous motor, if we give one frequency to the stator and its rotor frequency is a different frequency, so we can use this synchronous motor as a frequency changer. So for frequency changing, we have some types of electrical and electronic devices like cycloconverters, but mechanically Synchronous motor can be used as frequency changer. It is a mechanical type frequency changer or cycloconverter. Coming to the generation of three-phase rotating magnetic flux. When three-phase distributed winding is displaced by 120 degrees is excited by three-phase balanced supply, it produces a resultant magnetic flux rotating in space as if actual magnetic poles were being rotated mechanically. So 120 degrees electrical displacement supply is given to 120 degrees mechanical displacement stator, then it will produce a rotating magnetic field. It produces a rotating magnetic field with a speed of synchronous speed. It depends on frequency of the supply and the number of poles. See, generation of rotating magnetic field here. We are taking a three-phase supply. 5R, 5Y, 5B are the fluxes produced by the phases R phase, Y phase, B phase respectively. These three phases produce three different fluxes. These fluxes are 120 degrees electrically separated. So phi r is the phi max sin theta, phi y is the phi max sin theta minus 120, phi b is the phi max sin theta minus 240. These three fluxes are 120 degrees phase shift. 120 degrees phase shift. See, if we observe this three-phase supply, every 60 degrees, 0, 60, 120, 180, 240, 300, 360. Every 60 degrees, one phase is going to be 0. One phase value 0. Only two phases are present. Only two phases are present and one phase is 0. To prove for convenience, we will take the intervals of 0, 60, 120, 180, 240, 300, 380 respectively. Why? Because here one phase is 0, then we need to analyze only two phases. Only two phases. So the analysis is very simple. That's why I am taking at the intervals of 0, 60, 120, 180, 240, 300, 360. See, if you take the vector diagram, here I am taking phi r as the reference vector, then 120 degrees phase shift, I am taking phi y, again 120 degrees lagging phi b, phi r, phi b, phi y, all are 120 degrees spaced. 120 degrees phase displacement here. Here 120 degrees. Here also 120. This is the three phase vectors flux phi r, phi y, phi b. Three vectors are here 120 degrees displaced. So here for convenience I am taking the intervals of 0, 60, 120, 180, 240, 300. When I take 0 degrees, then what will happen? At 0 degrees, phi r is 0. Here, r phase value is 0. Then y phase, phi m sin theta minus 120. Here I am taking 0. 0 minus 120. So sine minus 120 means minus phi m sine 120, that is equal to minus root 3 by 2 phi m. Then I am taking phi b. Phi b is equal to phi m sine theta minus 240. Here and theta I am taking 0. Then sine 240, sine minus 240 minus phi m sine 240. That is equal to root 3 by 2 phi m. Root 3 by 2 phi m. Here I am taking, here phi r is equal to 0. Phi b here, and phi phi r 0, phi y, phi b. Phi y, phi b. Two, one is this direction, one in the direction. The resultant in this direction. Resulted in this direction. Means here phi r is equal to 0. Phi b and phi b resultant one direction. It is in one direction. Therefore, resultant flux is equal, phi r is equal 2 into root 3 by 2 pi m sine cos 60 by 2. These two resultant, I am taking a parallelogram. I am taking a parallelogram, and I am taking this value. This value is equal, I am applying the formula 2 into root 3 by 2 pi m into cos 60 by 2, because here it is a 60 degrees and this half is the 60 by 2. I am constructing a parallelogram, and the resultant value 2 into root 3 by 2 pi m cos 60 by 2 is equal to 1.5 pi m. 1.5 pi m. Here I am constructing a parallelogram, phi b, phi y. Then this is the resultant vector. This is the resultant vector. This is total 120 degrees. This angle is 60 degrees. This angle 60 degrees. I am constructing a baseline here. Baseline here. I am taking this triangle. This triangle is equal to root 3 by 2 phi m cos 60 by 2. And this is also root 3 by 2 phi m cos 60 by 2. Total value 2 into root 3 by 2 pi m cos 60 by 2, that is equal to 1.5 pi m. Now I am taking when theta is equal 60 degrees. Theta is equal 60 degrees. In this case, here phi b phase is equal to 0. Phi b phase is equal to 0. Phi r is equal to root 3 by 2 pi m, positive value. Phi y is equal to minus root 3 by 2 pi m, negative value, because it is below the horizontal line. So similarly, the resultant value phi r is equal to 1.5 pi m, similar to the first case. Here the resultant value is in this direction. Here I am constructing a parallelogram between y phase and r phase, resultant this direction. In previous case, b and y resultant is up direction. Now resultant is in this direction. Means it is rotated in clockwise direction. When we take 120 degrees, then phi r is equal to root 3 by 2 phi m. Phi b is equal to root 3 by 2 phi minus 12 minus phi m. Phi y is equal to 0. Resultant is equal to 1.5 phi m. Here I am constructing a parallelogram for R phase and B phase. The resultant is in this direction. In first case, it is upward direction. Second case, it is this direction. Third case, it is in this direction. Similarly, when theta is equal to 180 degrees, 60, 120. Here r base is equal to 0, then phi b is equal to root 3 by 2 pi m, because here phi b is the negative value. And apply theta is equal to 180 pi m sine 180 minus 240. Minus value, the minus root 3 by 2 pi m. Similarly, phi y is equal to phi m sine theta minus 120. Theta is equal to 180, 180 minus 120 positive value. That's why here we are getting phi y is a positive value, root 3 by 2 pi m. Now the resultant value is 1.5 pi m. If we construct a parallelogram, then we will get this resultant value. Then if we take 60, 120, 240 degrees, here phi b is equal to 0, phi r is a negative value, phi y is a positive value, then the resultant is equal to 1.5 pi m. Similarly, we are constructing phi y minus phi r parallelogram. Here the direction is this direction. So it is again rotated in a clockwise direction. When theta is equal to 300 degrees, phi r is equal to root 3 by 2 phi m, and phi y is equal to 0, phi b is equal to root 3 by 2 phi m. Again, the resultant value is the 1.5, but it is rotated. Magnitude is the same, but the angle of direction is different. So when we take 300, then phi y is equal to 0, remaining phi r and phi b. Phi r is equal to minus root 3 by 2 pi m, phi b is equal to root 3 by 2 pi m. Resultant value is equal to 1.5 pi m. If we construct a parallelogram, then this direction is different. So, similarly, for 360 degrees, phi r is equal to 0, phi y is the negative value, phi b is the positive value, resultant is the 1.5 pi m. When we construct a parallelogram, it is similar to the first case. Means 0 and 360 are both are similar. So, from these points, we can understand that first case resultant force is like this. Then second case magnitude is same, but it is shifted by 60 degrees. Again, 120 degrees magnitude is 1.5 m, but again it is shifted by 60 degrees. Then at 180 magnitude is same, but it is rotated. Again rotate again. So for 360 degrees, its resultant value also rotating 360 degrees. From this, we can conclude that the resultant flux rotate around the stator at synchronous speed as given by ns is equal to 120 f by p. 120 f by p. So from these two figures, we can understand resultant force is rotated from here to here, 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 here to here. Every 1 degree phase shift, 1 degree space we will consider is rotated by 1 degree. So means electrically 368 degrees rotation is equal to mechanically 360 degrees rotation. For complete one cycle, the resultant flux also completes one cycle. Okay. So today's objectives we are completed. So once we recall what we discussed so far, first classification of motors. We can classify the motors AC motors based upon the supply, based upon the location, based upon the speed, different type configurations. Supply, single phase, three phase, speed, constant speed, variable speed, adjustable speed, location, submersible, surface mounted, different types of classification we will discuss it. So we have discussed it. Then what is AC motor? AC motor, what is the motor? Motor conversion of mechanical energy into electrical energy into mechanical energy. Then comparison with synchronous motor. Synchronous motor is a constant speed motor. Asynchronous motor is not a constant speed motor. Advantages and disadvantages of synchronous motor. Synchronous motor has different types of advantages. That is the main advantages are its main advantages are power factor correction is the main advantage and constant speed. Coming to the disadvantage is a high cost motor. We need a DC and AC supply, double excited supply. We cannot run this motor for variable speed applications. Applications where there is a need of constant speed, there is a synchronous motor like centrifugal pumps, clocks. We use synchronous motors. And what is rotating magnetic field? When we apply a balanced three-phase supply to the 120 degrees mechanically shifted winding, then the flux rotates with a speed of synchronous speed with a magnitude of constant 1.5 max. Constant magnitude, but rotating in nature, field is produced. Okay, so up to so today's our objectives are completed. So if you have any doubts regarding this synchronous motor, uh, you can contact me on my mail nagaraju.addagatla nagaraju NAGARAJU dot addagatla 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 at gmail.com. You can also contact me through WhatsApp on my mobile number 9866930004 9866930004. Okay, so today's session we learned about synchronous motor and asynchronous motor. We had learned about the great advantages of synchronous motor, power factor correction, and constant speed of operation. Coming to the AC motors, everywhere AC motors are used, but all the loads needed variable speeds. That's why synchronous motor is not a popular in industrial applications, but it has the applications in power factor correction. But synchronous motor, induction motor has more number of applications because it need only one supply, but synchronous motor needs dually excited, doubly excited motor. Means it needs AC and DC supply, that is the drawback, and its initial cost very high. These two are the major drawbacks of this motor, but these motor have great advantages. Okay. Okay. So enough for today. Thank you. Thank you.